All right, let's talk about fractions. Yeah, I know. For a lot of us, that one word can bring back some complicated memories, right? You're shading in circles, you're trying to find common denominators. It can get a little confusing. So why? Why is something that seems so simple on the surface often so tricky to really master? Well, let's dive into it. Because it turns out there's this really powerful and actually pretty elegant idea that can clear all of that confusion right up.
Okay, so what is the root of the problem here? Well, it's because we basically ask fractions to be these little mathematical chameleons. I mean, think about it. Depending on the context, a fraction can mean one thing, like taking a part of a whole, a slice of pie, but then it can also be a quotient, which is just the answer to a division problem. Or it could be a ratio, where you're comparing two different things. Or it can even be an operator, like an action you're supposed to perform on another number. When our brains are trying to juggle all of those different meanings at the same time, yeah, it's no wonder things can get a little confusing.
So let's just get this out of the way. If you've ever felt like fractions have these multiple kind of confusing personalities, you're not wrong. You're absolutely right. They really do. And you know what? Understanding why that is, that's the very first step to seeing the beautiful, simple idea that actually connects them all.
I mean, just think about it for a second. When you see the fraction, say 3/4, what does that mean to you? Is it 3 slices of a pizza that's been cut into 4 pieces? Yeah, could be. Or is it the number you get when you divide 3 by 4? Or maybe you're comparing 3 red marbles to 4 blue ones. Or is it an action, like finding 3/4 of a bigger number? The answer to all of that is, yep, it can be all of those things. Okay, so let's actually take a quick tour of these different faces of fractions. We'll start with the ones we're all pretty familiar with, and then we'll move into some of the more abstract roles they can play.
All right, first up, the basics. On the left here, you've got the part-whole model. This is probably the first way most of us ever learned about fractions, right? 3 shaded parts out of 8 total parts. Super simple. Think pizza slices. But now, look over at the right. That's the quotient model. Here, 3 divided by 4 is asking a totally different question. How do you share 3 cookies among 4 friends? It's a completely different story, a different setup. But guess what? The answer for how much cookie each friend gets is the same number, 3/4. So different problem, same result. Interesting.
And believe it or not, it gets even more abstract. Fractions can go way beyond just describing a single object. As a ratio, for instance, a fraction is comparing 2 totally separate quantities, like the ratio of red things to blue things being 2 to 5. Or it can be an operator. This is a big one. It's a command to do something. Take 3/4 of 20 isn't just a thing. It's an instruction to perform an action on the number 20. So we've got the same symbols being used for very, very different jobs.
So, okay, we've got all these different personalities, right? Part, whole, quotient, ratio, operator. So how in the world do we unite them? This is where the big, powerful idea finally comes in. To really, truly get a handle on fractions, we have to make a shift in our thinking. We have to stop seeing a fraction as just a picture of a pizza or a set of instructions and start treating it as what it really is. A single number. That's it. A specific, unique point on the number line.
And that brings us to, honestly, the most powerful tool we have for making sense of all of this, the number line. By defining a fraction as one single location on this line, we create this one super solid foundation that all the other interpretations can rest on. And this, right here, is the real power of mathematics. It's about finding that one elegant definition that can bring a whole bunch of different ideas together.
Okay, let's build this up nice and slow, nice and careful. So how do we actually place a fraction on the number line? Well, first things first, we have to define the fundamental building block, what we call the unit fraction. So just take the space between 0 and 1. Got it? Now, you're going to divide that space, or partition it, into some number of equal parts. Let's just call that number b. The length of just one of those tiny equal parts, that is what we define as the number 1 over b.
Now here's the cool part. Once we have that unit length, our 1 over b, we can build any other fraction we want from it. So for example, let's say our unit fraction is 1/6. How do we find 5/6? It's simple. We just take that 1/6 length and we copy it or repeat it 5 times, starting from 0. And that exact point where we land, that is the number 5/6. It's a simple, precise, and totally unambiguous location on the line. And boom. This right here just illustrates the whole big idea perfectly. At the very center, we have our solid, rock-steady definition of a rational number on the number line. And branching out from it, you see all those other chameleon personalities we talked about? Part, whole, ratio, operator, quotient. See, they're not separate competing ideas anymore. They're just different ways to use or interpret one single concept,
a number. Okay, we're almost there, but I have one final, and I mean absolutely crucial, point of clarity to make. We've established that a fraction represents a single number, but to really lock this idea in, we have to be super precise with our language.
And this leads us to a really important distinction, the difference between the symbol and the actual thing it represents. You can think of it like this. A fraction, the symbol's 2/3, that's just the name for the number. It's like your name. But the rational number is the actual thing itself. It's you. It's that specific, unchanging point on the number line. The name isn't the thing itself.
And this right here makes it crystal clear. Take a look. The fractions 2/3, 4/6, even something weird like -6/-9, these are all just different names. They look totally different, right? But they are all pointing to the exact same spot on the number line, that one single rational number we happen to call 2/3. That's what equivalent means. They just name the same exact value.
And here's a fantastic way to think about it, to summarize the whole thing. When your teacher told you to reduce or simplify a fraction, like going from 4/6 to 2/3, you weren't actually changing the number. Not at all. You were just giving that number a different, maybe simpler name. The value itself, its location on that number line, it has not moved one single bit.
So if there's one big idea to take away from all of this, it's this. It's simple, but it really changes everything. Fractions aren't just parts of a whole. They are numbers. Real, solid numbers that have a specific place on the number line, just like 1 or 2 or 3. And once you truly see that, that's when the chameleon finally stands still.